Okay, so I was hoping to try to run through a question from each section that would be on the test, and I'm using the review. And so the first part is a functions review, and if we want to evaluate it, I think I'll do number 3, where we have g of x is 3x minus x squared, and we want to find g of 2x minus 1. So our class, I just want to try to say to take your time, and you've got to follow PEMDAS, that order of operations stuff, and you have to really follow the algebra carefully. So we're going to substitute 2x minus 1 in place of both of those x's. And when we put it into the g function, we're going to put it in parentheses. So we're sure that we're keeping it, putting it into the right spots, and that nothing is changing. I've got 3 times my something minus that same something, all getting squared. So it's super important that we're doing parentheses and we're taking our time. So in this first bit, we're going to distribute. So we get 6x minus 3. And then we have a minus, and we're going to start a parenthesis, because here we have to do exponents before we can subtract or distribute that negative 1. So we've got to write this down twice and go through FOIL. First, outer, inner, and last. And then we want to combine these terms. So we have 4x squared minus 4x plus 1. Now we'll think about this being a negative 1 right here, and we'll distribute with the negative 1. So rewrite 6x minus 3, and you get minus 4x squared plus 4x minus 1. Oh, I think I did this in second period. Combine like terms. Positive 6 and positive 4 is positive 10. Negative 3 minus 1 is negative 4. So just really take your time when you're evaluating. And we might also have one like number 6, where we have a piecewise function. And the first piece is an absolute value. And the second piece is this cubic. And for number 6, they want h of negative 3. This is your x. We have to see if our x fits this or if our x fits this. So we put our negative 3 here. Negative 3 is not less than negative 3. That's not true. So we won't be using this piece. And we put our negative 3 here. Negative 3 is greater than or equal to negative 3. That is true, so we'll be using this piece. So I'm going to rewrite it. Oops, I think this is a square. Second power. Okay, so now we're going to do negative, and let's put our negative 3 in parentheses. Everywhere we're going to plug it in, put it in parentheses. All right, when we go to try to do this term, we have to do exponents before we deal with this negative 1 out here. So we've got the negative of negative 3 times negative 3 times negative 3 is negative 27. And then when we do this term, we've got to do exponents first. Negative 3 times negative 3 is 9. Now we can multiply the negative 1 plus the 18, and we get 45. So take your time. 7 through 14, you just need to be able to recognize them if you see them on a graph. And I feel like there were some questions on 12 with the cube root. And it looks like, and I have posted your key on Google Classroom and your graph. So there is no asymptote here. It is going all the way down to negative infinity for the range, and it's going all the way up to positive infinity. So it's constantly increasing. Number 13, the reciprocal function is sometimes called the rational function. That's what I call it. And that's f of x equals 1 over x, which is why it's called the reciprocal, because it's reciprocal of the linear. And it looks like this. And number 14, there was some question about the greatest integer function. And it's that double bracket around the x. And it was the funny little step function, like, and then step up, and then step up, step up. Okay. Okay, the next section is transformations. That was 15 to 20, and I said you could omit 18. All right, so we'll do number 15 and 17, I guess. If the quadratic parent function is reflected in the y-axis, I'm going to stop right there. Already, I know I've got a quadratic parent, and a reflection on the y-axis means the negative is in here with the x, and then there's parentheses, like closed like that. And then it said, reflected in the y-axis and vertically compressed. Vertically compressed happens out here to the function, not inside. So vertically compressed would be by a factor of a half. So that's just a half times that. Write an equation to represent this new function. So there's our equation. I didn't talk too much about that y-axis reflection. If it's reflected on the y-axis, then it's going to fold from here over to here. That's a horizontal fold. That's why that negative goes inside. Anytime something's horizontal, it's inside the parentheses or inside the square root or inside the absolute value with the x. Number 17, the absolute value parent function has transformations applied such that it creates an absolute maximum. And maximum. Well, we know the absolute value parent function looks like this, which has a minimum. So if it has an absolute maximum, it's already been flipped over. So we already have a reflection over the x-axis. That means we have a negative out in front of the function. It creates an absolute maximum at negative 2.7. So right now, the parent has an absolute maximum at 0, 0. So if the maximum is at negative 2.7, some shifts have happened. So that is 2 to the left from where the parent was. So a left shift is a horizontal shift, so it's going to be inside with the x. It's the opposite of what it looks like. And it was shifted 7 up, so that is outside the function with a plus 7. Number 19. Describe all the transformations from the parent function, given the function below. Technically, we should start inside the parentheses and say, what's that half do? Or actually, we should get our parent as the x cubed. Now, what does that half do? Well, it's some type of a stretch or a compression. And if it's inside with the x, it's a horizontal. And it's the opposite of what it looks like. So it's a half, which is a little number, but it creates a horizontal stretch by a factor of its reciprocal. And then you could move to the 3. Actually, I would probably do the negative next. That negative is out in front, so that's a reflection on the x. And then the 3 is out in front, so that's a vertical stretch or compression. And since it's a number bigger than the fraction, it's not a fraction, it's a whole number, it's a stretch, because vertical is exactly like what it sounds like. And then this 7 is being added to the whole function, so it's up 7. So if you have trouble with these, I would go back and find those worksheets and practice some of these. All right, then I'm going to say we aren't going to do 21 through 23 because there's just a lot going on there, and I think it would just be intimidating. 24 and 25, we're only going to deal with discontinuities. We just didn't get to domain and range with it. So for 24, we have discontinuities. We have a jump at let's see, it looks kind of like this, and then it picks up underneath it like this. Whoops. I don't know how I did that. Picks up underneath it like this, and then it picks up underneath it like this, and it sort of does a thing like that. So as I try to trace it, from left to right, oops, I got to jump down here to keep going. So we have a jump discontinuity at x equals -3. And then we're tracing along, and then it goes, oops, let's jump down here. So we have another jump discontinuity at x equals 2. And then we trace, and then it picks up here. Well, when it does that type of thing, there's an asymptote. So we have a vertical asymptote, which is an infinite discontinuity at x equals 5. And those are all phrases you can get on your note card. As well as all these stretching and reflecting and translating rules. You can put that on your note card. Okay, then we aren't doing 26 or 27, 28, 29. That brings us to 30. 30 was covered on our quiz. We have x squared minus y squared equals 4, and they want to know if it has x-axis symmetry, y-axis symmetry, or origin symmetry. And there's a graph for us. So when I look at that graph and I just sort of start checking through these boxes here, first I want to check x-axis, so I'm going to do the test. Well, number one, I realized that if I folded it on the x-axis, that this part would fold over here and this part would fold down here. So it looks like it has x-axis symmetry. So when I do the test, it should prove that it does. So x-axis symmetry says leave x alone, but plug in a negative for the y. So you need to rewrite the equation and put parentheses around your negative y so you can follow order of operations. You have to do exponents before you deal with that negative. So we get x squared minus a negative y times a negative y is y squared. And then you compare to the original, and they're exactly the same. So that's our check that it does have x-axis symmetry. Now it also looks like it has y-axis symmetry, so the test for it is to plug in a negative x. Go back to your original, plug in a negative x, do your exponents first, and get a positive x squared. Compare that to your original, same. So yes, it has y-axis symmetry. Now let's do the origin test. We're going to plug in a negative x and a negative y. Being super careful with minuses. I do order of operations, do my exponents, minus, do my exponents, and that's the same as the original. So it checks that also. So it actually had all three types of symmetry. Number 32, it's the even, odd, or neither. And these symmetry tests, I hope you put those on your note card. Even, odd, or neither. And you've got negative 3x to the third plus 5x. So the test is plug in a negative x and see what happens. So it's negative 3 parenthesis negative x cubed plus 5 parenthesis negative x. Do exponents first. So it's negative 3 times a negative x to the third. And here we can just multiply. And here we can say a negative times a negative is a positive. And we're done. So then we compare. We had a negative 3, now we got a positive, so that's opposite. And we had a positive 5, and now we have a negative. So that's completely opposite, which means it's odd, which means we have symmetry with respect to the origin. It's all the O's. If you don't like the testing, like looking at the signs that way, then you could factor out a negative. And when you do, it is the negative of what we started with. So it's the complete opposite of what we started with, which means it's odd. Okie dokie. That brings us to operations with functions. Next to last topic. So I'm going to work number 35 with you. Please pay attention. This is a multiplication dot. It is not h of f. So it's just multiplication dot. So we'll just do h of x times f of x. So we'll write down what the h of x function is. And we'll multiply it by the f of x function. And then you just say, can I multiply these together? Yeah, we can just FOIL. So it's 3x squared minus 2x to the third minus 15x plus 10x squared. Normally you would put these in order with the highest power first. So negative 2x to the third. You look at your x squares and you get plus 13x squared. And then your just x's leaves negative 15x. And if you get like a square root times another square root, and you can't remember if you can do it or not, if you can multiply them together under the root, then you can just try some nice numbers on your calculator and see if it works both ways. And by the way, you can multiply different roots like that. So the last topic on the test is the composition of functions. Make sure you see that this is the f of g and not f times. So I would say write it friendlier first. And then you see g is inside of f. So we're going to scoop g up and put it inside of the f function. So take g and you're going to put it into those x's in the f function. So it's a negative parenthesis square root x plus 7 squared minus 2 parenthesis square root x plus 7. So f still has the same format. Negative of something squared minus 2 times that something. Negative of something squared minus 2 times that something. Alrighty, so now order of operations says exponents first. So you got a negative of. When you square a square root, you have freed what's underneath the root. And then on this part, you can multiply that negative 2 times that understood 1. And now, for this first term, now you can distribute your negative. And none of these terms are like terms, so we would be done there. And I do not know if I remembered to take 40 and 41 off of your review, but we are not going to decompose functions, so you can omit 40 and 41. All right, let's do our last one. Let's do 44, because some people stayed with me at lunch and we looked at 44. So it's g of h of negative 6. So that's g of h of negative 6. So g's function is the cube root of 2x minus 3. And h's function is 1/2 x plus 5. So first off, we want to do h of negative 6. So we're going to do h of negative 6 and plug that in. So it's 1/2 times negative 6 plus 5. Multiplying fractions, you just go straight across. So it's negative 6/2 plus 5, or negative 3, because we could have reduced them first right here, plus 5. So it's 2. H of negative 6 is 2. So we're going to replace h of negative 6 with 2. And now you're going to go to the g function and you're going to put 2 in. So you're going to go to g and put a 2 right here. I'm going to do it right under because I'm running out of room over there. So it's the cube root of 2 times 2 minus 3, which is the cube root of 4 minus 3, which is the cube root of 1. And 1 times 1 times 1 is 1. So the answer is 1. Alrighty, that is me running through one of each. No way do I think one of each is enough. No way do I think these problems on this review is enough. I think you should take each of these topics and spend some time going back and looking at your worksheets where you evaluated functions and try some of those. All the keys, I believe, have been posted. If not, you can ask ChatGPT what the answer is. I think it takes pictures. If you take a picture of your math problem, it'll work it out for you. Then go to your transformation worksheets. Try some of those. Then go to the discontinuities worksheets. Try a couple of those. Then go to your symmetry worksheets, which is getting pretty recent. X-axis, y-axis, origin. Then go to your even, odd, neither worksheets. Try some of those. Operations with functions, where we're adding, subtracting, multiplying, and dividing. Try some of those. And last, those composition of functions worksheets.